Hello everyone, welcome back to Equilibria. So today we're going to continue with our topic 2 under Equilibria, still module 1 which is matter and transformation. So we're going to continue with topic 2. Topic 2 is acid-base equilibrium. So we're going to start with definitions.
Arrhenius.
Arrhenius definitions. Arrhenius definitions. 1. According to Arrhenius, an acid is a substance that dissolves or ionizes in water, producing H plus as the only positively charged ion. So we can materialize this using an equation. Also, according to Arrhenius, an acid is a substance that ionizes in water, producing OH minus as the only negatively charged ion. So, according to Arrhenius, a base is a substance that ionizes in solution, producing OH minus as the only negatively charged ion. On the other hand, an acid is a substance that ionizes in solution, producing H plus as the only negatively charged ion. So according to Arrhenius, an acid is substance that produces H plus in solution. A base is a substance that produces OH minus in solution. So according to Arrhenius, an acid is characterized by H plus. A base is characterized by OH minus. Okay, we can go down to the next definition. Brønsted and Lowry. Brønsted and Lowry. According to Brønsted and Lowry, an acid is a proton donor. A base is a proton acceptor. So consider the acid-base reaction below.
Acid plus water
Giving
H2O plus
Cl minus. So in this case, we have an acid-base reaction. This is an acid and this is a base. Why? Because an acid is a proton donor. The acid HCl donates its proton to the base, which is water. So acid initially is having is HCl. This proton, the proton is H plus, is given to water. That is why water is having now 3 protons to form the oxonium ion. The oxonium ion is having 3 protons. Then an acid is a proton donor. So here is the acid. Here's a base. Conjugate acid. Conjugate base. So a conjugate acid is a base plus proton. So base plus proton equals to conjugate acid. So a conjugate acid minus proton equals to conjugate base. So if you have an acid and you remove its proton, like here, if you remove the proton of HCl, we're left with Cl minus. So Cl minus here is the conjugate base. If we now take the base, I will add the proton such that there are 2 protons here plus 1 proton. We are going to have 3 protons. So I have H2O plus H plus. Having what? H3O plus. In this case, we have an acid, we have a base. We have a conjugate acid, we have a conjugate base. So according to Brønsted-Lowry, an acid is a proton donor, while a base is a proton acceptor. So let's take another example. So take another example. So let's identify the acid conjugate base pair. Let's start with the acid first. An acid is a proton donor. So in this case, we are checking the one that has donated the proton. A base is the proton acceptor. A base is a guy that has accepted a proton. So let's start with ammonia. Ammonia is having 3 hydrogens now. After ammonia is having 4 hydrogens. So ammonia has accepted a proton. In this case, here will be the base. Automatically here is the acid. So here now we'll go to what? Conjugate acid. Conjugate base. Conjugate acid, conjugate base. So this is the Brønsted-Lowry definition of an acid or a base. Then let's now see the Lewis definition. What is the Lewis? Lewis definition. According to Lewis, an acid is an electron pair acceptor. A base is an electron pair donor. So Lewis here is dealing with electrons. So Lewis, according to Lewis, an acid is an electron pair acceptor. A base is an electron pair donor. So consider the acid-base reaction below. N H H H F F. So let's now see what we can do. See you have H H. So let me repeat the definition of Lewis. According to Lewis, an acid is an electron pair acceptor. A base is an electron pair donor. So let's consider the acid-base reaction below. Ammonia has lone pairs of electrons. These electrons are donated to boron. In this case, ammonia is acting as a Lewis base. A Lewis base is an electron pair donor. So ammonia is donating electrons, a lone pair of electrons. Boron is accepting the lone pairs of electrons. So in this case, we're having boron that is accepting electrons. We have now ammonia that is donating electrons. So according to Brønsted-Lowry, this guy is a base. According to Lewis, this guy is an acid because a base is an electron pair donor, while an acid is an electron pair acceptor. So we're going to go now to the acidic constant or the acidic constant itself. So
hydrogen potential. Bracket pH.
So pH is minus logarithmic the hydrogen ion concentration. So you can have pH. pH is minus logarithmic hydrogen ion concentration. So that's the formula for pH. pH is minus logarithmic the hydrogen ion concentration. So you can have the pH scale. pH scale
7, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14. Zero.
So the pH scale starts from what? 0 to 14. So for substances with pH less than 7, so all of these guys are acidic solution. So increasing acidity, increasing basicity. So for substances with pH greater than 7, they are basic solution. Substance with pH less than 7 of acidic solution. So 7 now is the middle. For 7, for substances with pH 7, they are neither acidic nor basic. So pH 7 now. pH 7 are neutral. Neutral solutions. Neutral means they are neither acidic nor basic. They are in between acids and base. But if your pH is less than 7, you're acid. If your pH is greater than 7, you're basic. But you have to be very careful here. For substance with pH 1, pH 1 is more acidic than pH 6. pH 18 is more basic than pH 8. So for acids, the lower the number, the stronger the acids. For bases, the higher the number, the higher the basicity. So that's the pH scale. So the pH now is just to measure the hydrogen potential of a solution, or the quantity of hydrogen, the concentration of hydrogen in solution. So pH is equal to minus log the concentration of H plus. So let's now see the ionic product of water. The ionic product, bracket KW. So let's consider the partial dissociation of water. So water dissociate as give H plus plus OH minus. The equilibrium constant Kw. So let's take equilibrium constant. The equilibrium constant Kw is equals to concentration of H plus, concentration of OH minus. But concentration of OH minus equals to concentration of H plus, because water is basic. Water is neutral. For neutral solution, it has equal the concentration of the H plus ion equals to the concentration of the OH minus ion. So substituting the Kw equals to concentration of H plus times concentration of H plus. Kw is concentration of H plus square I can make concentration of H plus subject to the formula. Concentration of H plus equals the square root of KW. I can take minus log on both sides. I can take minus log on both sides. So taking minus log on both sides. How can you see? pH is equal to, let's take minus log on both sides. So remember, minus log of H plus equals to minus log of KW. But remember what I told you. Minus log of H plus is pH. So the pH of water is equal to minus log the square root of KW. So that's the formula. So KW is ionic product of water. We usually say water is neutral, meaning the pH is 7. So let's see a case where we can actually prove that water is neutral. Example. Calculate the pH of water at 25 degrees Celsius of if KW equals to 1 times 10 to the minus 14. So apply the formula. The solution. pH is equals to minus log the square root of KW. So apply the formula. pH is equals minus log the square root of 1 times 10 to the minus 14. pH is equals to 7. See point. So pH of water is 7, and all the substances having pH 7 are neutral. So water is neutral.